Okay, good morning. Today is Monday, January 23rd, 2017, and today we're talking about lesson 3.15. There are 16 lessons total in Module 3, so today we're talking about the second to last one, lesson 15, which also means your test on Module 3 will be this Thursday. Okay? What are the big concepts we've learned in Module 3? Like, since we're going to start preparing for the test, what math concepts have we learned about in Module 3? What are you responsible for knowing? Look back at your notes and see, what have we been working on? Junbuk, what's one concept we've been working on?
Equivalent fractions.
Ooh, we've been using equivalent fractions to do what? We've been using equivalent fractions to, Alina? Add and subtract fractions. Yeah, the big concept of Module 3 is adding and subtracting fractions. Did we first learn how to use equivalent fractions to do it? Or what strategies did we use all the way back in like lessons 3.1 through 3.7? What strategies did we use? Sonia? Yeah, we drew rectangular models to add and subtract fractions, and then we learned how to use equivalent fractions to add and subtract fractions. So today, our learning goal, since we're towards the end of the module, is we're taking all of that information we learned, how to add fractions and how to subtract fractions, and we're going to use that to solve multi-step word problems, and then also use benchmark numbers to decide if our answers are reasonable. So as we know, today's learning goal is all about solving multi-step word problems. And then we're also going to think about if we know our answer is reasonable or not. Anushka, please turn to your lesson 15 problem set. If you read the directions, it says solve the word problems using the RDW strategy. Remind me again, what does the R stand for?
Read.
Read. So your first step is to read. What does the D stand for?
Draw.
Oh, draw. And then what does the W stand for?
Right.
Right. So it's telling you when you solve these word problems, you need to first read the problem, then you need to draw a picture. What kind of picture do we like to draw the best? Tape diagrams, yeah. And then the W stands for write, which means you need to write out a math sentence, and you need to write your answer. Okay? So, Drew, will you read to us? What does problem number 1 say?
In a race, the second place finisher crossed the finish line in 1 1/3 minutes after first place finisher. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the first place finisher take?
All right. What is this question asking us to find? Michael? Okay. Yeah, we're trying to figure out how long the first place person took to run the race, okay? So let's figure out what important information do we need. It says, in a race, the second place finisher crossed the finish line 1 1/3 minutes after the first place finisher. And the third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. So make sure you underline what the question's asking and circle all the important information. Remember, that's our 1, 2, 3 strategy we do every single day. Those of you who would like to improve in solving word problems, make sure you do these strategies. Okay, how can we read the problem now, we did the R, we're up to the D. How can we use a tape diagram to represent or draw this problem? When we're running a race, who takes the longest? The third place person or the first place person? Third place person. So whose tape diagram should be the longest? Third. Okay, so let's draw the third place diagram first. And when we draw diagrams, we have to label them. So this is third place. And do we know how long the third place person took? How long did the third place person take? 34 2/3 minutes. So let's go ahead and label that. This is 34 2/3 minutes. Okay. Now, second place, should the tape diagram be longer than third place or shorter than third place? Shorter. So let's go ahead and draw a second place diagram. And we are going to label it second place. And do we know how much shorter? So this missing area over here, and what I like to do sometimes is draw like this. This extra area was how long? How much faster was the second place person compared to the third place? Yeah, so this part over here is 1 3/4 minutes. So how can I figure out how long it is from here to here? How could I figure out, if I know that the third place person took 34 2/3 minutes altogether, but the second place person was 1 3/4 minutes faster, how can I figure out how long it took the second place person to win the race? To run the race. Aditya?
You can subtract 1 3/4 minutes from 34 and 30.
Interesting. Okay. We also have a first place runner whose time was the shortest, right? And how does the first place runner compare to the second place? It says the second place finisher crossed the line 1 1/3 minutes after the first place. So this distance over here is how long? 1 1/3 minute. You got it. Okay. And the question is asking us to find how long the first place finisher took. So what would your first step in this problem be? What do you need to do first? First, we need to figure out how long the second place runner took, huh? Aditya, how were you saying I could take the third place time, 34 2/3 minutes, and I could subtract 1 3/4 minutes. And this would give us the time it took the second place runner to finish the race. Go ahead and calculate that. So in our first step, we could subtract 1 3/4 from 34 2/3 to find that the second place runner took 32 11/12 minutes to run the race. Using this information, how can we figure out how long it took the first place runner to run? Reagan?
Subtract 1 1/3 minute from 32 and 11/12 minutes.
Yeah, you just have to take the second place runner's time, 32 11/12 minutes, and we subtract the difference between the first place and second place, which is 1 1/3 minutes. Okay. Should we do method 1 or method 2 this time? Still do method 2? When I do method 2, I'm going to put this over here. Which fraction do I ignore? The 11/12 or the 1/3?
11/12.
Okay, so we're going to ignore that for now, which means I have 32 minus 1 1/3. What's 32 minus 1? 31. And then I subtract another 1/3, which is 30 2/3. Now I need to add back my what?
11/12.
Okay, so I have 30 plus 2/3 plus 11/12. What's my LCD now? Good, so I have 30 plus 2/3 times what version of 1? 4/4. And then do I have to multiply 11/12 by anything? Nope. Good. Okay, let me make some more room. Now, that means I have 30 plus 8/12 plus 11/12. If I have 8/12 and I add another 11/12 to it, how many 12s do I have? 19/12. So I have 30 plus 19/12. Is that more than 1?
Yes.
How many holes do I have there in 19/12? So I have 30 plus 1 and how many 12s left over? 7/12. So the answer is 31 7/12 of a minute. What does that number represent? How long it took the first place person to run the race. If we're going to go back and use benchmark numbers to make sure our answer is reasonable, it says it took 34 2/3 minutes for the third place finisher to run the race. 34 minutes and 2/3 of a minute is pretty close to what benchmark number? 35. Okay, let's say it took the third place about 35 minutes to run the race. How much faster was the second person? 1 3/4 minutes faster. That's pretty close to how many minutes? 2 minutes. So if it took third place 35 minutes, but second place was 2 minutes faster, how long did it take second place? 33 minutes. How does third place compare to first place? First place was 1 minute and 1/3 minute faster, which is pretty close to what number? 1. So how fast should the first place runner have done it? Around 32 minutes. Is that close to our answer?
Yes.
Yeah, so we're pretty sure that our answer is reasonable. So in this problem, we're trying to figure out how much salt John has left. He originally bought 10 kilograms of salt, and then he used up 1 3/4 of it on the sidewalk, and another 3 4/5 kilograms of it on the driveway. We're done reading the problem, which is the R. The D stands for draw. So even before you write a math sentence, shame on you if you've already written a math sentence, because it's R, then D, so we need to draw a tape diagram. Go ahead and see how you could draw a tape diagram to represent this problem. Okay, so both of these tape diagrams show that John originally, all together, have 10 kilograms of salt. Okay, because that's how much he started out with. Then, he first used part of it, so they sectioned off part of it, and they labeled it 1 3/4. Okay, do you guys see that both of these tape diagrams have that in common? Then he used another section of it, so they cut off another section, and they labeled it 3 4/5. Then there's a third section which represents the amount they have left, and both students chose to represent that using a question mark to show that that's the part we're trying to find. These two tape diagrams are excellent because they help us in our next step, which is W. We need to write a math sentence. Okay? So what do we first need to find? The first step, let's find out how much salt John has used. Okay? The first step is we need to figure out how much salt John has used up. How might we figure that out? Lakshan? Yeah, we can add 1 3/4 with 3 4/5 to figure out how much salt John has already used up. So far we've calculated how much salt John has used up altogether. But what's the question asking, Danielle?
How much does he have?
Yeah, so now that I know he's used up 5 11/20 kilograms altogether, how can I figure out how much he has left? How might I figure out how much he has left? Lakshan? So I can take his original amount altogether with the whole tape diagram, which is 10 kilograms, and I subtract the amount he's already used up, which is 5 11/20 kilograms. So what's 10 minus 5? Okay, so that equals 5, and I subtract another 11/20. What's 5 minus 11/20? It's going to be 4 and 9/20. And what's my label? Kilograms. Good. So, you know, we usually represent money in dollars and cents. For example, we could have, what's $1.50? It would be $1.50, right? Is this a decimal or a fraction? Decimal. How might I express this in a fraction? It would be, how many holes do I have? One hole, because I have $1. And then how much is the fraction? How much is the fraction? A DT? 1/2. Okay, because we know that 50 cents is half of a dollar. But what if we have like a different number? Like what if I have $1.85? Could I still express that in a fraction? What would be the whole number part? Everyone? 1, because I have $1. Is 85 cents part of a dollar, or is it a whole or a fraction of a dollar? Fraction. How many pennies does it take to make $1? 100. And how many pennies do I have here? 85. So what would my fraction be? 85 100ths. Now, could I simplify that? Because 85 and 100th are both divisible by 5. So it would be 1 and, what's 85 divided by 5? 17. What's 100 divided by 5? So $1.85 is the same as 1 and 17/20. So for example, sometimes I might ask you to write your answer as a fraction and in dollars and cents. Okay, so can we write money in fractions and in decimals?